Then objective 2, we want to analyze ellipses with centers at h comma k. So if we were to shift an ellipse at the origin whose major axis corresponds to one of the axes, h units horizontally and k units vertically, its center would then be at h comma k and its major axis would be parallel to one of the axes. So your major axis would now not be along the x or y axis, but it would be parallel to the x or y axis. And so basically, things to take away from this, when you move horizontally, you move h units. So you're going h horizontally, or the x term, and then your y term is going to be k units vertically. So our little chart here, we have equations of an ellipse center at h comma k, major axis parallel to a coordinate axis, so x or y axis. If our center is at h comma k, and our major axis is going to be parallel to the x-axis, then our foci are going to end up looking like h plus c comma k, or h minus c comma k, and then our vertices would look like h plus a comma k, or h minus a comma k, and then our equation would end up looking like x minus h in parentheses squared divided by a squared plus y minus k in parentheses squared divided by b squared is then equal to 1, where once again we have that a is greater than b, which is greater than 0, and b squared is equal to a squared minus c squared. So depending on whether or not your major axis is parallel to whichever axis, for example, it's parallel to the x-axis, you're going to take the values of your foci and your vertices, you're going to apply that to the x term of your center. If it's parallel to the y-axis, you're going to take those values and apply them to the y term in your center. So when we have it's parallel to the y-axis, we see our foci will be h comma k plus c and h comma k minus c. Then our vertices will be h comma k plus a and h comma k minus a. Then our equation would end up being x minus h parentheses squared divided by b squared. Remember that smaller value because it is not parallel to the x-axis. Plus y minus k in parentheses squared divided by a squared, so the larger value, equals 1, where we still have that a is greater than b, which is greater than 0, and b squared is equal to a squared minus c squared. So all right, reviewing that, we see that our ellipses are going to look the same. It's just that we've shifted our center over. So in our pictures here off to the right, we see our new ellipse that has been shifted, has a new center, but it's still parallel to the x-axis. And our second image B, still going to be parallel to our y-axis in this case, but the center is shifted. So all right, example 3, we want to analyze the equation 4x squared plus y squared minus 8x plus 4y plus 4 is equal to 0. So quite the equation there. So we're going to be doing a lot of rewriting in this case. So first things first, we want to complete the squares. For x and y in our equation. When we complete the squares, we know that we're going to take all of our x terms and all of our y terms, and we're going to rewrite them as something like x minus h or y minus k. We can rewrite them in this way if we complete their squares. So first of all, let's just kind of write things around here. So let's put our x terms together and our y terms together. So we can get 4x squared minus 8x, put that in parentheses, and then we'll say plus y squared plus 4y. And then we have our plus 4 is equal to 0. We want to get rid of that plus 4, so let's just go ahead and subtract that from both sides. So now we have 4x squared minus 8x plus y squared plus 4y is equal to negative 4. We have this 4x squared minus 8x. We don't want a coefficient in front of x squared, so let's go ahead and actually just pull that 4 out right away. So this will now leave us with x squared or 4 times x squared minus 2 squared. So, all right, we have that down now. Now we want to complete the square. So, for example, in our first term, we have x squared minus 2x. The way we would complete this square would be if we had our values of plus 1. In this case, when we complete our square, it is going to look like x minus 1 squared. Then to complete the square for y squared plus 4y, we have y squared plus 4y, and the term that would end up making this would be plus 4, which means that we have y plus 2 squared. So really quick, we're going to identify what terms we added here. We added a plus 1, and we also added a plus 4. So we added a plus 1 and a plus 4. But we have a coefficient outside of our parentheses that include plus 1. And sorry, that's not squared. So we have to take our coefficient 4, multiply it by 1 to get 4, and we add that. So 4 times 1. We added 4 times 1. Then our other term that we had, plus 4, has no coefficient, so we just add plus 4 again. So now, adding these values together, we get negative 4 plus 4 is 0, plus 4 is going to be 4. So we have 4 times x minus 1 squared plus y plus 2 squared is equal to 4. And of course, we want this in our proper form. So we're going to divide each term by 4 to end up getting x minus 1 squared divided by 1 plus y plus 2 squared divided by 4 is equal to 1. So here is our equation, or here's our equation in the form that we would like it in. So now, from this equation, we can very quickly determine what h and what k is going to be. If we know that our form is supposed to be an 8x minus h squared and y minus k, so this means that our center is at 1, negative 2. Since we have y plus 2, it's supposed to be y minus k, so that means that k is negative. So we have our center at 1, negative 2, and our major axis is parallel, not how you spell parallel to the y-axis. It's parallel to the y-axis because we see we have the bigger value in the y terms denominator. We have y plus 2 squared over 4 as opposed to our x minus 1 squared over 1. So our center is at 1, comma, negative 2. That's one of the things that we wanted to find. Now we want to determine our vertices and our foci, and then also what's going to be our x-intercepts. So we can see that a squared is 4, b squared is 1. So if we want to solve for c squared again, remember that it is going to be c squared is equal to a squared minus b squared. So we get c squared is going to be equal to 4 minus 1, which is equal to 3. That also gives us a c is going to be equal to the square root of 3. So our vertices, which if we remember, from our graph here, we have our parallel to the y-axis. So our vertices will be at h comma k plus a and h comma k minus a. So our vertices are going to end up being, our center was at 1 comma negative 2, so it's going to be 1 comma negative 2 plus 2, and 1 comma negative 2 minus 2, which are going to be 1, 0, and 1, negative 4, since we had that a was equal to 2. So our vertices are going to be 1 comma 0 and 1 comma negative 4. Then the foci are h comma k plus c and h comma k minus c. So our h was 1, k was negative 2, and we have 2 plus the square root of 3. Since c was equal to 3, that means that, c squared was equal to 3, so c is equal to the square root of 3. And positive 1, negative 2 minus the square root of 3. So there are our vertices and our foci. And now remember, we don't have to solve for our x-intercepts in this case, but it is helpful when we actually graph. So we see then the x-intercepts are going to be h plus or minus b comma k. So we have that h is 1, so we have we have 1 plus or minus 1, and k is still going to be negative 2. So this gives us our x-intercepts at 2, negative 2, and 0, negative 2. So while finding our x-intercepts is not crucial to analyzing our equation, it helps us a lot when we actually go to graph our ellipse. So the things we were looking for is that we wanted to find its center, then we wanted to find our vertices and our foci. So now we have everything we need to go ahead and graph this equation. So plotting our center first at 1 comma negative 2, right there. Then our vertices are going to be at 1 comma 0 and 1 negative 4. So we have our vertices here and here. So we'll say V1, V2. Then plotting our foci are going to be at 1, negative 2 plus the square root of 3 and 1, negative 2 minus the square root of 3. Negative 2 plus the square root of 3 is just barely less than 0, so it's going to be about right there. And negative 2 minus the square root of 3 is going to be just barely greater than negative 4. So our second foci is right there. And then we have our x-intercepts at 2, negative 2, and 0, negative 2. And now we can go ahead and connect our points. So we want to connect our x-intercepts to our vertices. And make sure that our foci are inside of our ellipse. So, all right. Then lastly, we have objective 3. We want to solve applied problems involving ellipses. So ellipses are actually very commonly found in many different applications of science and engineering. They come up very often in other fields, so it is helpful to know their equations and how to solve them. So example 4, we have the Whispering Gallery in the Museum of Science and Industry in Chicago can be modeled by the top half of a 3-dimensional ellipse, which is called an ellipsoid. The gallery is 47.3 feet long. The distance from the center of the room to the foci is 20.3 feet. Then we want to find an equation that describes the shape of the room. Then we want to know how high is the room at its center. So we have two things here. We want to find the equation, and we also want to know how high is this room at specifically its center. So we can set up our problem. For an ellipse with center at 0, 0. We can have our center be at 0, 0 since we have no real defined center in this case. So we're just going to say it's going to be at 0, 0. And it's along the x-axis. It's fairly safe to assume it's along the x-axis. This is a building, so thinking that it's going to be essentially the top half of an ellipses, it's most likely going to be much wider than it is high, but we will see that it is along the x-axis, considering that it's 47.3 feet long. So we have it along the x-axis. So the equation will be in the form x squared over a squared plus y squared over b squared is equal to 1. Then since the length of the room is 47.3 feet, the distance from length, the distance from center to each vertex will end up being 47.3 divided by 2, since we know the distance from one end of the room to the other end, so one vertex to another vertex is 47.3 feet. That means that our center, or our distance from our center to each vertex, so that C value is just going to be 47.3 divided by 2. So 47.3 divided by 2, or sorry, A, not C. Foci is C, vertex is A. So this will be our A value. This is going to end up being 23.65 feet. So A is equal to 23.65. Then we know the distance from the center to foci is 20.3 feet, which we were given. So then we get that C is equal to 20.3 feet. Then we know our equation of B. We know B squared is equal to A squared, so 23.65 squared minus C squared, which is 20.3 squared. And when we plug this into a calculator and calculate it, we get that this value is going to be 147.2325. So we can round up to 2 decimal places. We can say this is going to be about 147.23 feet. So our B squared value is about 147.23. Now we can solve for our equation. For our equation, we get that x squared is going to be over 23.65 squared plus y squared is going to be over 147.23. Remember, that value is already b squared. And this is going to be equal to 1. Now you can definitely make it so that they are both have denominators of terms that aren't just left in squared form. You can also write this as x squared divided by 559.32 plus y squared divided by 147.23 is equal to 1. You can express it like this as well. This is 3.225 technically, but we rounded up a little bit, same as we rounded up here as well. But you can write your answer in this form as well as leaving your 23.65 squared. But we do know that b squared is going to be 147.23, so we can leave it at that value. So up to you, either answer is considered correct. So we found our equation, but our question that we had was how high was the room at its center? This means if we want to find the height of the room at the center, that would be our y-intercept. That would be 0, b. And our positive b value, since we only have the top half, we're not considering 0, negative b. We're only considering 0b. So b is equal to then the square root of 147.2325, which when we plug this into a calculator is going to come out to about 12.1 feet. So the height of the room at the center is about 12.1 feet. So there we have it. A lot of deducing that had to go in a word problem. Luckily, we did not have to graph it if we didn't want to, although if you wanted to, you could definitely spend some time graphing this as well. So we see that these applied problems tend to be a little bit messier, usually with a lot more decimals and things like that. So, all right, that wraps up our section on 10.3. So I'll see you again in section 10.4.